everybody. Again, thanks for the introduction. I am an amateur meteorite hunter. Not by day, I work for Golden One down in Rosemont there. But if I'm not there, I'm probably running around the world somewhere in a very dry desert place looking for space rocks or chasing space rocks. So I've been doing this for many years, and there's 50 different presentations of it. So I was asked to pick one that I thought would be a good introduction, and I'm happy to come back anytime to dive into more science of meteorite hunting and meteorites and origins of the solar system and all that. This particular one is more sort of a little bit science, but more about the adventure and the fun we can have out in the field while we're hunting meteorites. So I'm going to start with a little bit of very basic stuff. I'm used to doing these presentations in K-12 outreach sort of environments. So first of all, that's an advert. I'm happy to come and do this at any school. That's Cub Scouts, Girl Scouts, so guides, whatever kind of organizations that would appreciate this. I'm happy to do that. And I've got, like I said, 20 different presentations, also sorts of different levels of science and different components of this work. All right, so this is probably remedial to a lot of people in this audience, but it's worth just quickly touching on what is a meteorite, where do they come from? They're space rocks. They come from other places other than on the Earth. Most of them from the asteroid belt. A lot of them which are disturbed by our friend here, Jupiter, with its gravity, disrupting these rocks, puts them into odd orbits, and some of them end up coming to Earth, right? The moon, these craters here. I've got some lunar meteorites here. I've got a Martian meteorite. You believe that they came from those bodies. Pretty solid evidence that they came from those bodies. At some point when something disrupted, then when maybe this crater got formed by something heavy, right? Probably threw off some ejecta that went into odd orbits, and it traveled the 200,000 sun miles to Earth. The same on Mars. I do have a big piece of Vesta here, and we're going to get into a little bit more of that later. The science behind whether it came from Vesta is a little more tenuous, in as much as we've been to Vesta, we've been in orbit around Vesta, we've done lots of science there. We pretty much know what it was made of. And this chunk of rock that was a meteorite, we can tell it was a meteorite, came from somewhere other than Earth, contained the same chemistry as Vesta. Is there another body in the asteroid belt with a similar chemistry? Maybe it may have been from there. That's as good as we can get right now. All right. And by the way, I prefer this is meant to be a lecture. Right? If you've got questions, interrupt me. Throw rock and fruit if you don't like what I'm saying. Let's have a dialogue if you would engage that way. All right. Very quick, you probably know this. This is one of my K-12 slides. You can tell. So meteoroids, the terminology, junk floating around in space. It hits the sky and turns bright and ruins all of our good astro photos. Junking it up. If it happens to hit the ground, that meteor becomes a meteorite. One of my pet peeves that I have is we have a meteor crater down in Arizona, right? It really should be meteorite crater, because that meteor, when it was a meteor when it was 1 inch off the ground. Question here, I like to see this. Where do they come from? But only this video in the share volume is too low. Well, okay. How about now? If I come over the other side, is that volume going to be better?
Yeah, it will be.
Is that better? Okay. Sorry about that.
That's okay.
All right. So yeah, meteor crater could be meteorite crater, right? Because when it was 1 inch above the ground, it was a meteor. And as soon as it hit the ground, it became a meteorite. Anyway, all right. So let's talk a little bit about the sort of some basics of meteorite hunting. All right. Fall, they come into two categories. You're either going to look for a fall, or we're going to go seek out a find, right? So a fall, the definition of a meteorite fall is we've observed it, right? So we've either seen it on a visually, so shooting across the sky, like up here, it's been reported. There are websites out there where people report meteorite sightings. Captured on video. Get a lot of that these days with Ring video cameras and that kind of fun stuff. We captured on weather radar. So what you see here is different weather radars catching these rocks. So there's how do I want to put this? There's a sort of stereotype of a meteorite comes screaming through the sky and comes in at an angle and hits the ground and blows up, right? That's not how meteorites fall. First of all, very few of them are big enough. If any meteorite that's big enough to be a glowing ball of fire by the time it hits the ground, you probably don't want to be anywhere near it, right? It's going to leave a very big city-sized crater. Most meteorites, by the time they've entered the atmosphere and they start glowing and burning up, they've cooled down by the time they hit the ground. I don't think anyone's ever, I don't know this for a fact, but I've never heard of anyone getting a fresh meteorite, seeing it fall, and then walking over to pick it up. But if they did, it's probably going to be cold, right? Most meteorites, as they come in through the atmosphere, even though they come in at oblique angles to start with, once they hit the air and the friction, they eventually end up hitting terminal velocity, and they end up falling like rain, right? Almost vertical. Quick question, Adam. Yes.
Yeah, were you mentioning seeing the meteor in the sky?
Yep.
And getting close to it?
Yeah.
Or are you mentioning somebody? There's a few situations, at least one I know, where a person was actually hit by the meteor.
There's one
that was,
yeah.
and this was in Alabama.
Yep.
In the 1950s.
That's all hit the radio, yeah. Yeah, one known actual impact on a human being down in Alabama. Old lady was listening to a radio and she hit her in the arm and back into a radio. But that's a good question. But I'll pick up on that here in a sec. These falls, you see, I put a dollar sign for provenance and volume there, right? There's a lot less falls observed because we can go find meteorites, ancient meteorites from history that fell 10,000 years ago, right? So there's lots of those around. There's not very many falls around. So just like anything, the less of something is, the more valuable it can be. And when you have all this provenance around a fall, it adds value to meteorites. So what you'll find, folks like me, there's maybe a dozen, 20 of us in the country, have bags packed by the door that when we get reports coming in of a boloid or a fireball that we think with enough science behind it hit the ground, because remember most of these burn up. If you've got evidence of them hitting the ground, we'll get on a plane and go spend real money on chasing this fireball. It's actually kind of fun because it's always the same faces you bump into. I don't care whether it's on the East Coast, West Coast, Canada, Mexico. You go to the site where we think it's fell and you bump into a bunch of friends from all over the country. That's the only time you see them out in the field. It's kind of neat. There's camaraderie there, because then you go out for dinner and beers after the search and all that. But anyway, finds. The problem with finds is longevity, right? You're going to see some photos and some stories of going to desert, the Atacama Desert, the Sahara Desert, to go for these finds. Why are we going to deserts? People think there are hot spots for meteorites around the planet. Meteorites fall evenly, as far as we know, all over the planet, right? The hot spots is where can you go find them easy, right? In the Atlantic Ocean, it's difficult to find a meteorite without a southern ring. Question?
Might have been a rhetorical question, but the simple fact of the matter is all your big meteorites that you see in the museums and a lot of the meteorites that you find come out of Antarctica and the Arctic, because you're out in the big field of white, you see something dark, it ain't vertical.
Yeah. And the deserts, right? Although there's ice and stuff there, they're very dry. There's not much precipitation there and very little liquid water. So yeah, Antarctica is a classic one. And just as a quick side note to that, another thing that makes it easy is the glaciers. So the glaciers are sweeping these meteorites down, and there's hot spots for them. But there are treaties in place. You can't just go to Antarctica for meteorites. Although that would be a dream of mine. I would gladly pay whatever I needed to go on a meteorite in Antarctica.
That can be arranged.
Oh yeah.
Yes, I have nickel iron meteorite from Antarctica.
Wow.
Kept my mouth shut, got it through custody, because I was on books. And then I had a physicist friend, check it for iridium, because I was taught that the gold standard for nickel iron meteorites is the presence of iridium.
Yeah.
It's iridium positive.
Oh, well.
It's not very big, not like that,
Yeah.
but
Well, that's pretty rare. Not many people. I certainly don't have any, or don't even know anybody other than yourself, maybe, that had a meteorite from Antarctica. But anyway, back to finds. The problem is, yeah, they fall in the ocean. I went on a meteorite hunt in Mississippi. Yeah, I have a home in Mississippi. So that was a favorite one, and I've got a piece of it here. You know, if it falls into a swamp, it's very difficult to A, find it in the first place, and B, if it sits there for more than a year or so, it's iron nickel in there. It's going to rust and disintegrate. So that's the difference between a hot spot and a cold spot. It's more about how long the ancient falls end up hanging out. Out west here, we've got lots of space. People are still finding meteorites in the desert southwest. Believe it or not, it's not all been hunted out. BLM land is a great place to hunt. I think the law is you can keep up to like 20-pound meteorite if you catch it on BLM land. It's yours to take home, finders keepers. The general rule in the United States, which complicates hunts, is meteorites belong to the person that owns the land, right? In different countries, it's very different, right? So Egypt is a good one, right? Egypt, they consider meteorites antiquities, and you can guess where I'm originally from with this accent, right? My birth country had a reputation of stomping around Egypt and taking what it wanted. So they passed laws about exporting antiquities, and meteorites are considered antiquities. Canada's got a good blend. The way they do it, anything found in Canada, you have to put up for sale for a year so that academia or a museum, a Canadian museum, can offer to buy it and keep it in Canadian soil. After a year, you can then get an export license. So the different countries have different rules about these things, and you'll find that the meteorite community is very ethical when it comes to following the rules of the road there. All right, next question. Let's get to the fun stuff. All right, a little bit about tools of the trade. These are all taken in. All of these taken in the field. Yep, I'll stick all of these in the field, and I'll hit on a couple of things here. So, weight and location, from a scientific point of view, is very useful data. We don't just wander around the desert or whatever, or a strewn field and pick up rocks and just throw them in our pockets. We're going to photograph it in place. We're going to get the GPS location of where it's found, get a weight of it, and stick it in a Ziploc bag. So these three tools: Ziploc bags, little scale so you can weigh it in situ, and a GPS so you can either take a picture of the GPS or write on the bag where it's from. I don't know if you can see here, but that altitude there is 11,325 feet. So I'll tell you there, that's probably taken in Chile in the Atacama Desert. It's all way up in the plains there. I've got a picture of our tents and camp gear here, right? Dry deserts are a great place to find meteorites because they last for thousands of years on the ground. First of all, they're generally hard baked, so if something lands there, it doesn't sink into the dirt, it just sits there for thousands of years. There's no fauna there, right? There's no flora there, no fauna there. It means there's no human beings there. It means there's no marriage, right? So you're bringing your own tent. And you can't read what it says in the sign, but this says Andrew's Tent, Nowhere, Chile, 2022. Right? So this was in, if anybody has seen the show Meteorite Man, Steve Arnold and I, a good friend, there's Steve Arnold right there. Steve Arnold, that's Steve Arnold. There's one of the shows that was shot at it's called the Monte Rocky Crater in Chile. We're going to see some other photos of that soon. But that literally is like a 5-hour off-road, build your own road where there is none sort of journey to find. The first time he went down there with another friend of ours, Jeff Notkin, they couldn't even get to it. So it was a second attempt to actually get there. I've got into this crater. I'll show you some better photos of that here in a little bit. But you'll see this. The two tools of the trade you gotta have. None of these fancy metal detectors and GPSs and all that's all great, but it's the eyeballs. You see the eyeballs up there at the top, right? And a walking stick with a magnet, right? That's all you need to find meteorites. No fancy tools. Walking stick with a magnet, and the primary reason for that is because there are a lot of little brown rocks in the world. If you bent over to pick up every little brown rock, you'd need a chiropractor within a day, right? Remember, you're doing this for maybe a week or two. So this is a sort of instant test as you're going around. The sort of it helps focus your eyes so you can be doing a scan like this, and when you see something look suspicious, there's a little neodymium magnet on there, which I've heard from the politics that get really expensive. Something to do with importing rare earth metals from China. Anyway, and me filling up the gas tank. I think that was in Chile. Yeah, there's no BP or Shell stations in the middle of the Atacama. You'll see these rental trucks. That's the other part of this. Remember, you're in the middle of nowhere, and if something goes wrong, you're on your own. There is no helping anything. Anyway, we bring a Iridium satellite phone just for like if there's serious medical emergency or something. But let's say you get a flat tire. Okay, if you've only got one spare tire and you get a flat, you're pretty much aborting for the day, getting out of the desert, because if you lose another one, you're going to be stuck. So it's time to abort the mission. So we typically bring 2 or 3 spare tires. So you've got to find a rental outfit, assuming that it's not your own vehicle. You've got to find a rental outfit that'll rent your truck with more than 1 spare tire, as an example. You got to bring your extra diesel or gasoline, depending on the vehicle, with you, right? You can't get stuck out there in the middle of the desert. It's got to be pretty much self-sufficient. What else can I do? Let's go back there on the tools. You see our metal detectors here. I'll quickly touch upon the use of metal detectors. So, because everyone thinks that's a really important tool to have, meteorite hunting. I've used metal detectors really only seriously twice in my meteorite hunting career. And I'll give you the 2 scenarios where I've used it. One was the hunt in Mississippi, because we were dealing with a lot of long grass. It was wet, and sorry, Mississippi and Grimsby. We'll cover those in a second. But whenever there's a chance it's underground, so the chance of it being underground is if the ground is very soft or it's overgrown, it's difficult to look. You can't visually see when there's lots of grass and stuff in place. Or very, very ancient falls. So there's one location in Chile, it's called the Imalac Streamfield, where it probably is about 15 to 20,000 years ago, that one fell. And over time, there's been enough dust and detritus blowing around, that they're right about 5 millimeters under the ground. So having a metal detector to swing by that particular fall it is useful, but that's about it. I've really only used it. So, investing a lot of money in metal detectors, unless you're going to be chasing a lot of fresh falls, like in the United States, where you might be on soft ground. It's not that good of an investment, really. All right. So I'm gonna give you a little bit of history on some of these stories here, on the good, bad, and the ugly experience. Grimsby, Ontario. I remember this one. I was getting to board a plane. Actually, my zone had been called, and I was waiting on the plane to get on the plane. And Steve called me and said, "There's been." And this is when I lived in Buffalo, New York. Right, and Grimsby, Ontario is. There's Grimsby, Buffalo is sort of like that here, right? This is Lake Ontario. Which Ontario goes around here, Lake Erie over here. Well, Buffalo's that's So he said, "Hey, there's been a fall. Looks like the rocks might have hit the ground because we had good data on it. Good weather radar data for Grimsby saying something had fallen. So literally, I aborted. Didn't get on the plane. Went home, grabbed my bags. Steve flew up, and we went out hunting. So this is the original data we got. This weather satellite. You can see this is Lake Ontario. above Grimsby here for those that can't see on the call. You can see some of the hits were over the lake. So it's like, oh, do we go for this one or not? Because literally you're paying for flights and taking time off work. And all that. It's always there's a big debate. It normally takes about 24 hours when a fall happens. So let's say something happened now and there was a big fireball. It takes about 24 hours for all the data to get out from the NOAA weather radar to the satellite for the calls to come in, people that got the video on their webcams, the local news, because we do triangulation work too. But if you get two videos, we can sort of roughly predict where it came from. It takes about 24 hours before you've got a really good set of data before the community on our little signal channel, we were all talking about it, sort of come to some conclusion about whether we're going to hunt it, right? And then it's about, okay, who's close by? I happen to be driving distance from this one. So even though this was iffy for me, for a couple of reasons, one, a lot of it being over the lake, it was an easy one for me. I didn't have to pay for a plane flight and I could drive home every night and sleep at home. It's only a 50-mile drive. So this one I hunted mainly because of the investment associated with it in time and money was limited. But you can see what we did here. So the weather radar data is interesting, right? Because it depends. Typically, you get more than one weather radar station. Most of this came out of Buffalo. I think we also had a station out of Erie, Pennsylvania, did it too. And you can see some slightly different colors. Those colors aren't intensities. It's where more than one radar picked up the hit. So maybe the light blue is maybe only Buffalo got it. Maybe the slightly darker was Buffalo and Erie. And I think there was one up in Hamilton, Ontario as well. Maybe that's the darker blue one there, got hit by three radars. But that's a certain height, right? Depending on if you imagine a radar goes out and on non-rainy days, which this was a non-rainy day, they adjust the angle, these weather radars, what angle they're pointing at the sky. So it's either their longer range or their higher resolution, depending on what they're looking for, whether they're looking for rain or general scan. But based on that, it will tell you roughly what altitude this hit was at by getting it. But this is all about collecting this data, right? It's quite scientific. We need to know what mode the weather radar was in, how far the weather radar was from this particular site, and to be able to do this sort of triangulation. But in general, these are going to be 5,000 to 10,000 feet somewhere in that range. And like I told you, by the time they're getting hit by the radar here, they're probably falling vertically, right? And they're cold. They're no longer a bright firewall. So you then have to add on, okay, where they actually land on the ground is more about the wind direction. Okay, because they're falling vertically on a windless day, they will be directly under this hit. But if it's wind, it's floating. I'll leave that. Only to the water here, or they're coming in. This was a pretty quiet day from a wind point of view, so we determined the search was pretty close to where the radar hits were. So what you see next to us here is our GPS map. We drove every one of these roads, right? looking for these rocks, and the other complication is November 2022, it was snow, right? That adds another dimension of fun, but also a bit of adventure. Hey, I did a meteorite hunt in the snow. That's kind of cool. But unfortunately, that's what we found. All right. Anyone that's watched the show Meteorite Men on TV? Steve, that's the Steve Arnold. There's Steve. He coined the phrase meteorons. So we're looking for meteorites, we found meteorons. The reason we got a lot of that junk is because it was very grassy. So we were walking by the sides of the roads, lots of tall grass. So we would try to use our metal detectors and we'd get hits, but it's a very urban area that fell. So there's all this junk that we end up pulling up. So that particular hunt scored 0. I would say if I've done 20 meteorite hunts, I would say at least 30 to 40% of them you come back with nothing, right? So, and you got to get used to that. It's sort of like fishing, right? This is more, to me, this is more about the adventure and getting out there and living and doing some crazy things. If I get a meteorite as well, that's great. But if I don't, it's a time game. You just got to get time in the field. Sooner or later, you're going to get it. All right, next story. Cranfield, Mississippi. I have. Where's my Cranfield? Oh, here it is. This is a little space rock that I found in Cranfield, Mississippi. I did find one. So you know the outcomes. But this again fell in a relatively urban area. We got some wonderful weather radar data, mostly out of New Orleans and I think Mobile, Alabama. We've got that data out. It was a windy day, so this arrow up there you see is sort of our prediction of the strewn field, which is what we call it the heavy end and the light end of the strewn field. So where it starts dropping rocks is typically on obviously side here. These will be small rocks, and these will be big rocks. Bigger rocks have more momentum, so they typically will last longer. So will fly well because they've got more momentum. We also got it on the weather satellite down here. My home in Mississippi is right down here. It just so happened I was in Buffalo that day, so I had to fly down. I flew down to Mississippi home. Sea flew home, and we drove up. This particular one, again, it was in a urban area. The little red X, by the way, is where I found. It was in an urban area, but very grassy. So this, we talk about adventure. Steve is a nut job. We got on eBay and got a cheap ride-on lawnmower and bought it on eBay down there. And then went to Home Depot. We built a magnet rake. I don't know if you can see here, but there's these magnets. We tied them to the bottom of the 2x4s, put them on hinges, and dragged it behind. Let's see, driving the magnet rake here on the to try to find these ones in the grass and cover a lot of area. Now it turns out we struck out. Didn't get any using this tool. I don't think we tried it again, but yeah, it was fun. This one was just found on the side of the road, right there. There's my my magnet set with the extra lucky fireball tape on it. It worked on this one. So yeah, that's this little rock. And when we're done, by the way, you're welcome to come look, feel, and see these. But that's this little 2 gram. This is 2.6 grams. And it's an ordinary chondrite, and I'll talk to you here a little bit about that in a sec. But 2.6 grams. I only think there was maybe 100 and some grams found by this meteorite. So value of, like most things in life, it's not just how good they are, it's how little or more there are. So there's very little of this on the planet. So this little 2 gram rock, I'm going to say is probably worth somewhere around $400 a gram. So this might be $1,000 meteorite, right? When you think about gold right now, it's just shot up, so it's probably about $90 a gram right now. This is probably worth $500 a gram, right? So if someone offered me a 2 gram piece of gold or 2 gram Cranfield meteorite, take the meteorite. All right, so ordinary chondrite, H535. This is not science class tonight. There's a whole another 2 hours we can talk about how to classify meteorites. But it's a very interesting story to share, because there's this little bit of a tension between academia and private collectors, right? Because pure academics will say, well, if you go out and find a meteorite and you put it in a private collection, unless you're doing something like Andrew, like where I'm here sharing and doing tours and stuff with this stuff, it's out of the academia purview, and it's not out there for the public good in museums and that kind of thing. On the flip side, academics can't afford to send teams of people out in the field hunting meteorites for weeks on end, right? They need funding to do that. So the interesting sort of middle ground that most meteorite hunters follow, it goes like this. So the Cranfield meteorite, there was 100 grams per pound of it. It was shipped down to, this particular one went to University of Arizona Meteorite Studies. And the arrangement is that we ship amateurs, and there's no law about this. This is just sort of a code of ethics. We share our finds with an academic institution. They will typically cut off 10% of it, do the analysis, do the X-ray interferometry, determine what kind of meteorite it was, where it came from. You know, like I told some of you here, I've got pieces of Vesta and pieces of the Moon, pieces of Mars over here. How do we know that? because the scientists zapped it with an X-ray interferometer gun, determined what it's made of, and said, yeah, it came from Mars, because we've been to Mars and we know what's there, right? And they get to keep that 10% for their own studies, and that becomes part of the academia, right? So that's the trade-off. We can't afford to buy $1 million X-ray whatever that word is, X-ray analysis tools, and they can't afford to send people in the field to not find meteorites a lot of the time. Right? So that's sort of how that works, and it works out real well, I think. All right, that's how I know that that's an H35 ordinary chondrite. I think it's funny they call them ordinary chondrite, but there's nothing ordinary about a meteorite. But anyway. All right, now we get to some of the more exotic stuff, and I'm going to speed up a little bit. Then, what time do I need to be done? 8.
We're good to go past it.
Okay, well, okay. So this is where I mentioned this is part of this the lore LORE of this is the adventure, right? So I don't know if you noticed, but here this was a fall, right? Because we saw it. It was seen. It fell 8 o'clock in the morning. We got the data on it. So this was a fall. That date should be 2022, not 2. Mistaken. These are finds, right? So the purpose of going to the Atacama Desert for 2 to 3 weeks was to go to places where people hadn't been before and see if there's any rocks at the top. Right. In this particular case, the thing about the Atacama, it's the driest desert in the world, right? It just doesn't rain there. I mean, there's not even flies there when you're walking around in the desert, right? It's actually kind of creepy that for the first day, at least, half the time your ears are ringing. It's so quiet. Your body's not used to not having zero noise. Sometimes you can hear the blood moving in your ear or your heart beating even. Until your body reaccustomizes to this new normal, it doesn't know how to filter out this lack of noise. So yeah, Atacama. It's an interesting place. It's about 12,000 feet, 11,000 feet much to there. You fly into this town called Antofagasta on the coast, and when you drive inland, after about half an hour, you're already at 10,000 feet. That's what keeps it so dry. The sea air comes in, hits those mountains, goes straight up, cools it down, and just drops all of its moisture, so it just doesn't rain the Atacama. But as part of that is, and I'll put this picture down here in the bottom right. You'll see there's no tracks, there's no nothing there, right? Cars have been on this planet, what, 120 years, something like that. I forget when we invented the automobile. And nothing happens in the Atacama. So even if 100 years ago a car drove across that desert, the tracks would still be there. So it's easy to find virgin ground in very, very barren deserts, because if you see no evidence of man being there, there hasn't been any. Right? So you can drive around and see tracks, and you just keep driving until you don't see track, and now you know you're on virgin territory. This is another picture on the bottom left here of the Monterocchi crater. It literally is, like I said, 4 or 5 hours driving off road to get there. I was the primary driver in this trip, and so Stephen and my buddy Dennis, half the time we were stopping, they were jumping out, moving rocks to get through, or rearranging rocks to fill holes so that we actually had a road to get there. Very, very sort of pilgrimagey kind of place for meteorite people to go to. It's very, very difficult to get there, and you really don't want to get there. This is the only meteorite crater on the planet that's still producing meteorites. Like you can go, because we sort of spitballed it and said, I wonder how many people have been here, like in this place in the desert. And we figured maybe 100 people had ever been there, right? It's that remote. So you can still, it's obviously an ancient event that occurred, but you can still go there with a metal detector and pick rocks out of the ground. Really small ones, but they're there all the same. Yeah, and a picture of us eating dinner at a Peruvian restaurant in a very rough part of Chile, but just to sort of demonstrate the adventure there. Sometimes it's not all about the meteorite hunting. It's going weird places and doing crazy things. All right. Yeah. Okay. So I am also an astronomy geek, That's how I get connected with you guys, and I love astrophotography. And this picture here of the southern part of the Milky Way, that was one shot on an Ioptron modded, IR modded, I think it's a T3I or something, I forget what I used there. But it was a single shot on an Ioptron for about 5-10 minutes, something like a 50mm lens. That was kind of fun. Another great thing about the Atacama is where the Europeans keep a lot of their telescopes at the Paranal Observatory, and you can schedule tours there. So we've got to look around the Paranal Observatory there. In the bottom left here, this was taken in Buffalo, New York. So Dennis and I were Steve's not that Steve Arnold. He's a pure meteorite guy. He's not really an astronomy guy. But Dennis and I are into astronomy too. And we've never seen the southern skies. It's like, okay, we know our way around the northern hemisphere, but what about the south? Well, we knew a guy that one of the high schools in Buffalo back in the late 60s, NASA sponsored a bunch of planetariums to be in high schools to build public interest and support for the Apollo program, right? So there's a few of them still remaining in Williamsville, North Buffalo, still has a planetarium there. So we got to spend 4 hours on a Saturday. Fast forwarded the curator there, put the right date in and the right latitude and longitude. So we sat for 4 hours under the skies that we were gonna see when we went on this trip. So that was a kind of a neat experience. We walked out there. I said, "Well, how many people in North America just spent 4 hours in the Atacama Desert looking at the sky?" You know, but it was neat, and yeah, polar alignment is just a whole nother thing in the summer, right? So it's a lot of fun. As far as what I got out there, it's not always about just space rocks, right? This is field jasper, just a sedimentary rock that comes in all sorts of different colors. So sometimes you find other things in the middle of the that are fun. I didn't bring it today, but once in the Sahara, we were about 500 miles inland in Morocco, and I found some seashells. Encrusted seashells, sort of in almost cement-like material, showing that the Sahara Desert was once under the ocean, right? Just a little thing like that, and neat. But yeah, not much out of that trip. You can see a few little pieces of shrapnel and other stuff. The black stuff at the top, on the top right there, the unclassified trail. The black stuff came from the Monterocchi crater, that big crater. These other little ones came from a place called Iraq. I've mentioned to you, it's about 10,000-year-old fall. All right, last one for you, and then we'll switch to sort of show and tell and questions as you like. Morocco, different. The Sahara Desert, very different desert than the Atacama. As you can see, it's cloudy. It rains sometimes in the Sahara, I believe. Huh? And yes, there are some scrubby sort of plants around. There's a fly or two. There's real things happening. There are Bedouin tribesmen. That was the neatest adventure. So the Bedouins, they're not like the nomads that just sort of wander around. Like the Bedouins generally set up shop in different places for a while, and they had tents and that kind of stuff. But we didn't speak any Arabic, and they didn't speak any English. I speak some French, which is only good in like Casablanca, the big cities. It's not good out in the field. But within 5 minutes, we were in their tent, sitting on the ground, and they were pouring us tea, right? And we learned that when you're wandering around the desert, there's this sort of almost camaraderie amongst fellow travelers, sort of attitude, right? So of course they're going to invite you for tea, because who wouldn't want to rest after your weary journeys through the desert, right? You know, we're driving a truck, of course, but that's their mentality, right? I don't think that would happen in the United States, where you just get invited into someone's house and drink tea randomly in the street. You'll notice here that this is the first time we've seen pictures of the natives, so to speak. Morocco is an interesting place because Moroccans are very, very open and friendly, particularly to US citizens and Westerners in general. However, Algerians are not. In fact, Algeria has got a lot of political issues that we won't go into, and they're basically fighting war. They're at war with Morocco for all intents and purposes. And out in the middle of the desert, just want to, out in the middle of the desert, there's no line down the sand that says, okay, this is Morocco and this is Algeria. And if there was ever we think we're safe because we've got GPSs, but you know, if someone's coming at you with a weapon, you want someone local there with you to sort of help talk the situation down. Go ahead.
Morocco has an amazing amount of sedimentary rock just loaded with fossils. You can go to many places and see these big. And they're happy to let you mine it and take it out and everything, but I mean, they've got just miles of the stuff.
My fantasy, because I saw it being done there in a lot of like nice restaurants in Casablanca, is they make countertops out of slabs of fossils. So it's hard like marble, probably more like quartz or something, but it's full of fossils, and they carve it into, you know, the 1-inch slabs, and they make kitchen countertops out of it. I went, oh, could I get one of those at home? But not feasible. Maybe in retirement, you get a shipment of that.
I guess I won't tell you about the wall I have. It wasn't a table.
This rock here, that rock right there. Well, so this, and I'll tell you a little bit about this one. So, a fresh meteorite, relatively fresh meteorite, is going to be blackly colored, right? Can't get something to hear me. Meteorites. By the way, this isn't what it looked like in space. Meteorites ablate, like, you know, burn up. About 90% of them of the material burns up. So this was 10 times the size before it hit the Earth's atmosphere. So there's no, this isn't what they looked like when they were floating around, right? Plus, this was molten at one point, so that's why it's got the divots in it. That's what causes these, they're called regoliths, these sort of thumbprints. This was molten at one point, and it coming through the air, the wind sort of carved those divots in there, right? But they're black, right? So why is this one brown? Well, this one landed in the desert, sat on the floor, and based on the color and the weathering pattern, or we call it desert patina, right? That color probably puts it about 3,000 to 4,000 years ago. So this entered the Earth's atmosphere 3,000 or 4,000 years ago, sat on the ground in the desert. The land came along with his magnet, put fire, right? And rescued it. And that's the other thing, right? About the academia argument. Well, this would still be in the desert if I hadn't gone and collected. So what's the argument there? Go ahead.
Well, if I recall correctly, the discoloration is due to manganese setting on the surface, and you can measure the distance of the deposition to get your time frame. Am I wrong, or?
You're a level side above my paper.
Okay.
So I don't know about that. We always use the color because they get that, like, or another good example is this guy. This guy is a local, right? Or relatively local. This came from Canyon Diablo, the meteorite crater, or meteor crater, whatever you want to call it, down in Arizona, in Flagstaff. And this is probably 10,000 some years old, and you can see this is about ready done with being on this planet. It's going to fall apart pretty soon. All right, so there's that sort of rough aging approach from coming. And I think this is my last slide coming up. Yep, there you go. And I'll tell you one last little story. We're not too, when we go on a meteorite hunt, we're not too proud as to how we get them. As long as we get them legally, ethically, right? Two other ways of getting them. One is down in Mississippi, a lot of private property. You can't just go hunt in someone's backyard. You can't just go around their backyard and look for meteorites. But it's all private property down there. A few little public parks or the roads, good places to look. Because A, they're hard, right? They're easy to see the meteorites, and B, they're public. Anybody can walk along them. And the law in the United States, if it's on public land, less than 20 pounds, you can take it home. But we have postcards, right? So we put pictures of what a meteorite looks like, and on the back, we'll say, hey, we're here, we're the meteorite rescue company, guys. If you'd like us, if you find anything that looks like this, call us this number, and we'll come and buy it off, basically. So sometimes we get those calls, and we put sometimes knock on doors. If someone's got a big empty backyard or a farmer, we'll knock on the door and ask permission. 25% of the time, say, sure, go ahead, do whatever you want to do. Another 25%, they have a shotgun and you turn away and go away. The other 50%, you can either say, I'll tell you what, we'll split it 50-50, anything we find, or here's $50 if you let us hunt on your property, right? So no one's too proud to do that. The other way to do it is this. This is that piece of vest that I was talking about. You can come and see this closer and feel it, touch it if you want. You'll see down here, it's a Eurocrate purchase, right? I got this, it was part of a bigger rock, and I'll tell you what happened to the rest of it in a second. Part of a bigger rock, and I purchased it at a shady looking market in Casablanca. All right, this was for sale. Someone picked it up from the desert floor, and it was sitting there for sale. Right. So I was telling you about the academia and how we get them classified. If you look here, down here it says classification ATD achondrite based on mineral composition textures. It goes on to say probably from Vesta specimens and Hartridge towards the main mass. So what happened here? And this is from the meteorite. There's a bulletin part of the Planetary Society that keeps a log of all the known meteorites that fall and been classified. This was part of a bigger rock. We shipped this down at Arizona University. They took a slice off of it, did the analysis, and this is their wording. They did the analysis and said, "Yep, this is a Eurocrate, probably from Vesta," and shipped us back the other 90%. We cut it up, and it's in private collections now. And some of it went on to be sold, offset some of the cost of the trip. But the biggest chunk that's left of a find is called the main mass. So typically, like if a natural meteorite came in and it blew apart and it formed, a big oval shape of rocks, we could tell they're all related, right? But the biggest one was called the main mass. That's historically where that phrase came from. But we still use that same sort of phraseology when you cut it up. So this for that particular meteorite is the biggest part of it. And it's always registered who has the biggest part of it. So if in academia they ever want to go back, they find something special in here and they want to see the rest of the biggest part of it, because we can't track all of this stuff as it gets cut up and just sliced and diced, and who knows what happens to it. We always document who had the biggest chunk of it, so that data is available. That if someone in academia ever wanted to come back and do further analysis of a bigger chunk of it, they know where they can find it. Right? So that's the history of that part. And that's it.